Hi, everybody. We are back again to look at the next section of Chapter 5, which in general is going to be creating and solving exponential equations, as you can see in front of you. This first video, we're going to be solving exponential equations. And in our second video, we're going to be looking at creating exponential functions that pass through specific given points. For these equations, we're going to be using some specific steps to solve them for x. And you want to make sure you take notes on part 1, part 2, and part 3 of these steps and write those down in your notes. Don't worry about writing down these examples. We're about to do them on paper together step by step in just a moment. But the main thing to keep in mind is that we are going to be looking at exponent rules to help us to do this process. To show you specifically what I mean about those exponent rules, let's move to some notes here now. So you can see the top of my page above where I'm going to be starting the equations. You can tell I have two different exponent rules. So negative exponents are going to be important here. So if I see something like 1/4 or any 1 over anything or other fractions like that, I'm going to be writing it as something 1 over 2 squared, the lowest base I can find, and then making it into a non-fraction, 2 to the power of negative 2. This is sort of the opposite of what we usually do. We are usually trying to get rid of negative exponents, but now we're trying to get rid of the fraction and turning it back into a negative exponent. You could also be looking at this power to a power rule, where if I have 2 cubed that's being squared, well, that means I need to do 3 times 2 in those exponents, and it's going to end up being equal to 2 to the 6th. Both of these rules are going to be very important in the equations we're about to solve. The main features of these sorts of equations are we're going to be looking to try to get the same bases, as you saw in those steps I showed to you a moment ago. In number 1, this is the most obvious because we have a 3 as a base in both sides. And as you could probably guess, well, if I have a 3 in the bottom of both sides, well, that means whatever their exponent is going to end up being, they have to be the same as each other. For instance, I could write this whole thing as 3 to something equals 3 to something. Well, those are obviously equal. They're the same. So I just need to get these two exponents to be the same. So if you have the same bases already, both being 3's in the case of number 1, I can basically just get rid of those two 3's and then look at what the exponents are and set them equal to each other. So now I have 2x minus 1 equal to x plus 2. So we just have a couple of steps left to solve this two-sided equation. And in this case, we just subtract x from both sides and add 1 to both sides. And that ends up giving us x is equal to 3. Not required, but very often it's a good idea to check your work as you go to see if you did it right. So let's check that just for this first one. We will be doing 3 to the 2 times 3 minus 1 should be equal to 3 to the power of 3 plus 2. Some quick solving gives us that 3 to the 5th ends up being equal to 3 to the 5th, which is definitely true. Now, in number 2, we are seeing the first case where it becomes a little bit more challenging. 2 and 4 are certainly not the same thing. Now, if I want to get them to be the same thing, well, I can very easily write that as the left side staying the same, but 4 I could write as 2 squared. Now they certainly are the same base, and from there I can just look at their exponents, 3x and 2 on the right side, and I can solve it and get that my answer is 2/3. So in the following example, in number 3, I see, well, now I have my first fraction example. So I need to try to figure out how I can make 1/9 to have a 3 in the bottom. So the way I can do that is I'm going to leave that left side exactly the same and write the right side as 1 over 3 squared. And then I'm going to take one more step and write that as 3 to the negative 2, using that negative exponents rule that we mentioned earlier in the video. Now we have the same base, so I can then look at what my exponents are. Well, I need 2x minus 1 to be equal to negative 2. All I got to do is add 1 to both sides and then divide by 2. So we can do that right now, giving us negative 1/2 as our answer. Now, number 4, well, we see that we have a 1/2 and a 16, which means we have to do some things to both sides, which makes it a little bit more challenging. So let's do that first. Well, 1/2, I'm going to write as 2 to the negative 1. And the x minus 3 in the top didn't change. Remember that when you see 1 over 2, that 2 in the bottom is kind of like it has a 1, which we can then move to the top, and it's going to be negative. The 16, if you know your powers, is going to end up being the same as 2 to the 4th. The 3x plus 1 not changing. So now we have an example where we're using powers to a power. So we have to then kind of use the second exponent rule we mentioned above. So I'm going to need to do negative 1 times x in minus 3 on the left side and use 4 times 3x plus 1 on the right side. But the 2's and the bottoms are not going to change. So I can even write those first if I wanted to. So I'm going to do negative 1 times x, negative 1 times negative 3, and then 4 times 3x, and 4 times 1. So I got negative 1x plus 3 and 12x plus 4. Well, now all I got to do is get rid of those 2's and then solve negative 1x plus 3 equal to 12x plus 4. From there, like we've seen before, we just got to do some quick solving. So I could add x to both sides and subtract 4 from both sides. Give me negative 1 equals 13x. And from there, I can just finish it out by dividing by 13. Meaning that my answer, a little strange, negative 1/13th, which you can make into a decimal if you wanted, but as you hear me say all the time, that's usually an extra step, but certainly fine if you'd like to choose to do that. So we then have one kind of higher difficulty level problem, which will be the last one of our equations here on my next page. So now we see a problem here where we have a 4 to the power of 2x and 8 to the power of x minus 1. Well, there's no one number that will get us to a 4 and an 8 if we raise it to a power. I can't do 2 square. Well, I can find the 2 there would be the common base, is what I'm trying to say. So I basically am going to write it as 2 squared to the 2x, and then 2 cubed to the x minus 1. And now, well, I'm going to do what I did before. I'm going to do 2 times the 2x, 3 times the x and the minus 1. So I have 2 to the 4x and 2 to the power of 3x minus 3. I'm almost done with the last problem here now. All I got to do is solve 4x equal to 3x minus 3. And well, that means if I subtract 3x from both sides, well, now I have x, or 1x, is equal to negative 3. And that basically covers all the types of problems you would see. The only thing you kind of have to be aware of in this situation is the possibility that you could run into a quadratic equation, but that is not very likely in what you guys will see. So we will cover that later if need be. And now we will move into writing exponential equations in our next video. And I will see you then in that.